In the beginning there was nothing, no time, no space, no matter. Only an infinite singularity and unfathomable concentration of energy, then an explosion of unimaginable power. The Big Bang. In an instant, the universe expanded at an incredible rate, faster than the speed of light. The very fabric of reality unfolded, giving birth to time and space itself. Within the first fractions of a second, a searing hot ocean of fundamental particles, quarks, electrons, and neutrinos, filled the infant universe. As temperatures cooled, quarks combined to form protons and neutrons, the building blocks of all matter. After 380,000 years, the universe had expanded enough for atoms to form, allowing light to travel freely through space. The first cosmic dawn had begun. For hundreds of millions of years, the universe was a vast, dark expanse, its hydrogen and helium atoms drifting through space. Then gravity began its delicate work. Vast clouds of gas collapsed under their own weight, igniting nuclear fusion at their cores. The first stars were born, massive beacons of light that lit up the darkness. These giants lived fast and died in spectacular supernovae, forging the heavier elements necessary for the creation of plant and life itself. From the remnants of these ancient stellar deaths, galaxies took shape. One of these was the Milky Way, our home galaxy, and within one of its swirling arms, a vast cloud of gas and dust began to collapse once more. A new star system was forming. At its heart, a young star ignited. Our sun. Around 4.6 billion years ago, the sun's birth was accompanied by a vast swirling disk of gas and dust, material left over from countless generations of stars before it. Within this protoplanetary disk, countless collisions occurred as tiny dust grains stuck together, forming larger clumps. Over millions of years, these clumps became planetesimals, the building blocks of planets. The young solar system was a violent place. Collisions between planetesimals were frequent, sculpting a chaotic landscape of molten rock and drifting debris. One of these young worlds, battered and shaped by relentless impacts, would become our home, Earth. At first, Earth was an inhospitable sphere of searing heat. The energy from impacts, combined with internal radioactive decay, kept the entire planet in a molten state. But as time passed, Earth began to cool. Heavy elements like iron and nickel sank to the core, forming a dense metallic center, while lighter materials formed a rocky crust. With this process, the foundation of Earth's magnetic field was set, shield that would later protect our atmosphere from this intense radiation. But Earth's infancy was not yet complete. New disaster loomed. Mars-sized protoplanet, now known as Theia, was on collision course with our young planet. Moving at incredible speed, Theia struck Earth with unimaginable force. The impact melted both worlds, sending vast amounts of molten rock into orbit. This cosmic catastrophe reshaped Earth forever. The molten debris ejected into space formed a thick ring around the planet. Over millions of years, these fragments gradually coalesced, drawn together by gravity to form a single massive celestial body, the Moon. The Moon's formation played a crucial role in Earth's future. As it settled into orbit, its gravitational influence stabilized Earth's axial tilt, preventing chaotic shifts that could have made the planet inhospitable. It also generated the first tides, stirring Earth's oceans. Vital step in the evolution of life. With the Moon in place and Earth's surface solidifying, the planet entered a new phase. But conditions remained extreme. The atmosphere was thick with carbon dioxide, methane, and ammonia, while the land was barren, devoid of soil or vegetation. Volcanoes spewed toxic gases, and asteroid impacts continued to reshape the surface. Yet even in these hostile conditions, the foundations of life were being laid. Deep beneath the surface, hydrothermal vents provided warmth and minerals, creating chemical reactions that would one day lead to the first biological processes. Within Earth's young oceans, chemistry gave rise to biology. Simple organic molecules combined, forming amino acids, the fundamental building blocks of life. Over millions of years, these molecules organized into self-replicating structures, eventually giving rise to the first cells. The first life forms were microscopic, single-celled organisms. Around 3.5 billion years ago, cyanobacteria emerged, capable of harnessing sunlight through photosynthesis. These tiny microbes released oxygen as a byproduct, gradually transforming Earth's atmosphere. As oxygen levels increased, Earth's biosphere changed dramatically. Some organisms adapted, while others perished in what became known as the Great Oxygenation Event. This paved the way for more complex, multicellular life. From cosmic dust to the first spark of life, from a molten inferno to a thriving blue planet, Earth's story is one of chaos, resilience, and transformation. The forces that shaped our planet are still at work today, a reminder that we are part of a universe in constant motion.